All right, good afternoon, everybody. Thanks for coming in here for the last session. I know it's been a long 2 days now, so hopefully this will be interesting to end up the conference. Let's go a little bit more about my background. I work in Trustwave SpiderLabs. There's a lot of different teams in there. I work on the research team. My area of expertise is web application defense. So we have like a pen testing group, so I'm like the reverse, right? I try and protect the websites from guys like them. So on Twitter, if you're on Twitter, my Twitter handle there, Ryan C. Barnett. What else? ModSecurity, it's an open source web app firewall project. ModSecurity itself is not an OWASP project, but the rule set that I'm going to talk about is. So that's the, I think you asked the question, the CRS we'll talk about, it's the core rule set. So we'll get into that. Obvious affiliation with OWASP, why I'm here running that project. I also contribute to the AppSensor project, which we'll talk about as well. Do some instruction at SANS Institute, and shameless plug for my book, Preventing Web Attacks with Apache. So what are we going to talk about today? I'm trying to visually break it down for you into 3 different groups. First of all, by show of hands, who has heard of AppSensor before and knows what it is? Cool. All right, so the first circle over there we'll go through rather quick. I just want to make sure if people had no idea what AppSensor was, we at least want to catch them up a little bit before we dive in an implementation of pieces of it. The little circle on the right, we're going to talk a little bit about the idea of AppSensor detection points and doing response actions, doing it inside the code, which is what AppSensor promotes, and I promote that as well, but sometimes you maybe can't do that. So if you want to try and implement these externally to the code, what are the pros and cons of doing that? Just to get a level set to make sure you're not having different expectations. And then finally, down at the bottom, I want to show it's actually an effort that's underway right now. It's not complete yet, but what we're doing is taking these detection points that we're talking about from AppSensor and implementing as many as we can within ModSecurity, so external to the code. So we'll run through some examples of how we've been doing that, where we're at, and if anybody has any interest in helping out afterwards, just let me know. Okay, so AppSensor, what is it? The best way to look at this from a real-world analogy perspective is try and look at a bank. And looking here, kind of the schematics, right, the overview. On the right-hand side are all sorts of different security controls that you should have, right? And if you look around, you can see, of course, you have the armed guards coming in, guarding the money as it's coming in, going out. You have police down at the bottom, right? If there's a problem, you step on that silent alarm, basically incident response, right, coming. The front doors are guarded in such a way, right, they can be locked off. You have security cameras scrolling around. I mean, all these different things make sense, right, in the physical world. And off in the upper right-hand corner there, you have the safe, right, so the money's hidden off in a secure location. Now, the problem is, if you take this analogy and you try and apply it to web applications, unfortunately, most of the ones that are today, it looks more like this, right? And that's the big question, like, would you bank here? Now, the problem I think most people have is when you go to a site to purchase a widget or doing whatever you're doing, you have no idea that this is the actual schematic of the application you're working with, right? You assume it looks like the other one. But then you have all these different problems, right? Incident response, they may or may not come. It may take them a half hour to get there. It may take them 2 days. You never know. The security cameras, a lot of times, maybe they're pointed over here away from the doors, right? Somebody didn't set them up correctly. You have people with no training. There's like back doors to get in the safe. I mean, there's all sorts of problems that looking at this, that does not look like a place you'd want to bank. So it's those kinds of things that you need to address in your applications to make sure you have those types of defenses. Now, another way to look at this is I did a blog post over the summer after going out for Black Hat and DEF CON in Vegas. And when you're forced to hang out in a casino for a few days, runs through your head about, how does this relate to application security? So it was interesting when I was thinking about it, the whole paradigm of the previous screen, and everybody talking about historically network security, how it used to be the castle defense, right? Network firewalls, close everything off, keep the bad guys out. But in today's web apps, that really doesn't apply. Of course, we all know port 80 and 443, they're open. Unless you have specific types of application layer inspection firewalls, they just let that stuff through. So you can't just keep bad guys out. So what I thought was interesting is how do casinos do security versus what we just saw with the bank, right? Because when you think about it, a casino isn't standing there at the front door and every person coming in doing ID checks and whole TSA kinds of things. They let everybody in. But they've instrumented their architecture, right? They have the smoke cameras everywhere. Everybody's trained appropriately to know when processes aren't working right. They have incident response, right? It happens quickly. Maybe it's happened to some of you before, right? Cattle prod. take you out. So it was just interesting looking at that to say, hey, it seems to me that casino security and surveillance actually applies a lot more to most of the web apps that are running today. So you can try and take some lessons learned. How do they do security? One of the things that was interesting in researching this just a little bit is gaming commissions and casinos. Right? They have very specific prescriptive advice, saying, okay, if you're setting up cameras, here's like one standard 2, requirement surveillance coverage, table games. Very, very specific, right? Go here, if you're running a table game, you have to do these kinds of things. You have to make sure your camera can see every player's cards, right? Make sure if they're switching stuff around, you gotta be able to see chips, you have to be able to watch the dealer. Very prescriptive. So you know if they go in and get audited and check it and they don't capture that, you got a problem. So in looking at all this, I was like, wouldn't that be great if they had that type of prescriptive advice for applications? Other than something like PCI, which is probably as close as there is, it doesn't get to this level, right? Section 6 and 6.6 and all those things, it's talking generically. Oh, block cross-site scripting. Doesn't tell you how, doesn't tell you where. So I'm like, that would be really cool to have something like that. So that's really what AppSensor is aiming for. Okay? Project AppSensor, go to OWASP. Most people had their hands up, so you know where to find it. This was a recent article that Colin Watson, who's in here, he's helping project lead. They helped to do this article for, is it Crosstalk? Crosstalk. But you can go out and check if you want to read up on the full article. It's really good, especially like elevator pitch kind of stuff. If you want to give this to management or somebody, it's a real good overview, good read. But it talks about this, creating attack-aware applications and real-time defense. Okay, so that's also a piece that I think is missing in a lot of applications. Maybe there's logging that's being done if developers are writing exceptions and things like that. But they're not really monitoring for like trends or when things are happening and how do you respond to that? I mean, it's great if you flag that somebody put something in a field they shouldn't, but if they're repeatedly doing that and trying to break in, you maybe want to take some different actions against that user. So the AppSensor project, if you want to go check out, there's all sorts of stuff you can download. We had the AppSensor Summit here on Wednesday. There's like a cool promo video they're working on. There's a demo site you can go play with. So there's a lot of cool stuff if you want to go read about it. One thing that's a bit interesting, if anybody was in here previously, Jason Lee gave the talk about projects and stuff. It was like a 15-minute talk. AppSensor is like some other projects at OWASP where it's not just documentation or tools or code. It doesn't fit neatly in there because it's really a couple pieces. There's definitely a documentation piece, which we'll go over briefly here about the detection points. But then there is a code portion, right? Because most people are like, oh, this is a great idea. I'm running Java. I need some code snippets, right? Help me to figure out where I hook these in. So it's both a documentation project and a code project. So detection points, what are these really? The way that I would explain this, if you were going to talk to developers, really, and sit down at the table and try and figure out how to implement this, all the places in the code that they're probably already going to be writing exceptions for, where they're checking stuff, right? If this, Boolean, yes or no, then do something. And they're probably already going in there to write an exception. The issue, from my perspective, is AppSensor is getting developers to instrument their code properly so that when it's run in production, not by them, right? By operations, you're giving them operations intelligence to know that something bad's going on, right? It's not something just, oh, we've had a bunch of exceptions today. Well, what are they? I don't know. It can be more prescriptive here and say, oh, this looks like this is SQL injection or, somebody's tampering with this hidden field. It's a little bit more intelligence for ops really to know what's happening. This is one way to look at detection points and kind of break them down. On the left-hand side, you can see a lot of these parent categories are more traditional kind of signature-based. You have request exceptions, authentication session, all those. There's some newer ones down there at the bottom, honey trap. And then the other one, which is kind of cool, is more behavioral. So we all know about cross-site scripting, SQL injection. Yes, those need to be dealt with. But then other sorts of maybe external data feeds that you can correlate. In discussing this as well, AppSensor is kind of a good blend between traditional, maybe IDS, IPS, WAF, and web fraud detection. It's kind of putting those two together and then instrumenting your code to do all that kind of stuff. Response actions is kind of the flip side of this. And this is really where I think extending out what developers are doing already really helps in operations for incident response. On the left-hand side, you have all these different actions, and you can pick and choose. Maybe if one thing happens, you want to do something specific, log it, or deny the connection. If a group of things happen, maybe you want to react differently. Maybe at that point you say, hey, if there's been this many alerts in a certain time frame, now we actually want to get a little more aggressive and forcefully log that user out, or lock their account for a period of time. There's all sorts of different ways you can respond. But it's up to you to figure out, working through, with InfoSec and different groups policy-wise, how do you want to react under scenario A, scenario B? But there's a lot of different ways that you can do this. So one example, taking this again from some other slides that were out there already for AppSensor. If you're going to use this, let's say also with eSAPI, you can easily piggyback on top of eSAPI code and hook in. This is showing here just, number one, check for maliciousness. eSAPI is probably already doing that for most of those cases. Then you can just add in another line, another hook, that would then call up a detection point. So this type of detailed logging, if you're feeding it out to maybe other systems, like if you have SIM and a NOC and a SOC and people really monitoring all this stuff, that's really going to help them to understand what's happening. So looking in the code, that's the ideal place to do all of this, right? Because you have all the data you need to make these decisions. But inevitably, you get to the issue of, what if I have applications that I can't do this to? Right? We're responsible for them, but we didn't write the code. Right? It's kind of a black box. It's a third-party app. But I still want AppSensor type functionality. What do I do? So that's where I want to talk a little bit about doing these detection points and responses inside the code versus external, and things to consider with either choice that you make. So inside the code, it is the best place to do this. Because specifically, talking from my background, which is web app firewalls, trying to do this externally, this is the perfect example of where that model fails, right? External devices really have no concept of access control and authorization. And this is the classic example. ID equals 1002, you're authorized to see whatever you were looking at, your pay stub or whatever. But if you just toggle that to a different ID, and it shows you somebody else's, an external device is not going to know that, right? It's not an injection attack. I don't see anything malicious. You're just looking at something you're not supposed to look at. So keep that in mind, that if you're going to try and do these detection points, there's certain categories in these detection points that you might not even be able to do. But that ends up being a question of risk, right, that the business has to decide on. I was talking with somebody earlier about this as well, and the example would be if you had a group of applications, maybe half of them, you have the developers, you develop the code, you go in, you do all this. The other group, maybe you can't do it all, but externally you could try and put these detection points in and get some of this protection. Okay, so outside of the code, what are some challenges? Well, we just highlighted one of those, about the whole context with authorization and access control. Some other issues are if you have encoding issues. If anybody's played around at all between the differences with PHP and ASP and Java and all of that, certain ways they handle different encodings, some nuances there. Another one that we talked about at the summit, if you've ever heard of the attack, HTTP parameter pollution. Right? Different platforms handle it differently if you have multiple parameters that have the exact same name. When they make it server-side, like ASP, for instance, we'll take all of those payloads, condense them into one, and then it just shows one parameter. That's an interesting nuance to understand. Says you can miss that if you're looking for certain attacks. So there are some good things, and I'll highlight here where an external device can actually excel at giving you some protection. But we just want to make sure you're doing a good compare and contrast here. This is obviously on an app-by-app basis. So this is the big issue, and why I kind of decided to try and take some AppSensor detection points and put them into the core rule set at OWASP. That's because you have a lot of people that are using third-party apps. And they're like, oh crap, there's a new vulnerability just released for whatever, and we're waiting for the vendor, and they're telling us they're going to get us something whenever, but in the meantime, you're exposed, you know you're exposed, and the bad guys now know you're exposed, right? Because they monitor all those same mailing lists. So that's the idea. You want to get some protection in as soon as you can. The other thing to highlight here is platform issues. So if anybody remembers over the past year or so, a lot of these slow denial of service, targeting the web layer, This is actually a tool that OWASP helped to develop so you could test your applications. Part of this was based on, if you read RSnake's tool and stuff he had, Slow Loris. The idea is, as opposed to traditional network flooding, where in this case you're not sending hundreds of thousands of web requests from a botnet, you can send requests from a much smaller group of servers, or actually you can do it with a few clients. You open up that three-way handshake, you send part of a web request, but in this case you don't send all of the headers. Right? It's HTTP standard, has to be followed by control line feeds before the web server says, oh, I got everything. Well, based on the timeout settings on your web server platform, in Apache, by the way, it's 5 minutes. You could send that and just sit there and wait. Every minute or so, send one more request header. And you perpetually just keep that open. So it's a very easy way you can DOS the web server platform, and in that case, it never even makes it to the application code. So there's certain scenarios like that where you can't develop your way out of that scenario, right? So that would be helpful externally if you can spot that stuff and flag it, block it, take some sort of action. This was another interesting concept talking about implementing these detection points. So if you've been to a lot of OWASP stuff, right, and I know it's mainly developer focused for a lot of these things, secure coding and eSAPI. Right? It makes sense to everybody who's doing development that if you're getting, let's say, doing input validation for a certain parameter field, to say, I can do either or a blacklist or a whitelist. Ideally, you'd want to do positive security, right? Define a whitelist, saying, hey, this parameter called product ID, guess what? It should only ever be digits, nothing else, right? If it's anything besides that, just block it. That way, you don't have to worry about cross-site scripting, SQL injection. That makes sense, and developers will do that. The issue then is when you start to get into blacklists, like, okay, could you also go in and say, well, if you see any tick marks, just block it. I mean, that only really makes sense if you can't do a whitelist inspection. Now, taking this a step further, though, if you're going to talk about implementing AppSensor, we got another detection point. It's a further categorization or classification of something that would fail, in this case, your positive security. So you're already going to throw an exception to say, hey, I was expecting digits. It's not digits, exception, right? And you would log something. This would do another check on that data to say, let's apply a regex or something that goes against that payload and tries to identify SQL injection. Okay, now, conceptually, I think OWASP has done a pretty good job of talking to developers about what SQL injection is and how they should build, parameterized queries and all that stuff. But if you ask developers to say, we want you to implement this detection point and go off and figure out all the blacklists for SQL injection, I think that's asking a little too much, right? That's not their job to keep tabs on every nuance of SQL injection that comes out. They should be doing positive security, right? Saying if we don't have this input, block it. So this, to me, is where you get into if you can have not internal or external, but both working together, is a pretty cool concept. And we'll talk about that here in just a second. So the OWASP ModSecurity core rule set. As I said, it's OWASP project. Go check it out. You can download the rules. It's a base set of rules to give you base level protection, essentially. The idea is you can take these rules, plug them into any platform. It doesn't matter if you're running PHP or Java or ASP.NET or whatever. It doesn't matter. And you can see some of the bullet points and some of the stuff we're looking for. It's general badness that's easy to spot. A lot of bad clients, you check header fields. You look for the stuff like we were just talking about, cross-site scripting, SQL injection, but we have a lot of different methods to detect that. So what I wanted to try and do was to get more specific and go through all of the AppSensor detection points and then try and take those and migrate them in. So this was actually the first one that I started to tackle. It's the request exception category, and you can see now it's broken out from the parent down into some subcategories. So some of this stuff is pretty straightforward. If you wanted to go in and try and write a rule or something that would look for this and block it, that's pretty easy to do. The issue is with ModSecurity, I get this question a lot. How is ModSecurity different from other commercial web app firewalls? ModSecurity doesn't have automated learning and profiling. That's really what most commercial WAFs try and do because they're targeting input validation. But what it does have is a Lua API. If anybody's heard of Lua, it's a real popular scripting language in the gaming industry because it's very fast. And it's it's very easy to embed it in other applications. If those of you familiar with Nmap, right? They added in a Lua API, I don't know, a couple of years ago, and it's become pretty popular. The idea is if the tool can't do what you want, use the Lua API and you can do custom logic. So I took it upon myself to try and implement these detection points in ModSecurity using the Lua API to try and do some basic learning. So I ended up doing some of that. Let me see here. Had a blog post that we did recently just to show some examples. I did want to show some here. Oops. So implementing this stuff, if you're in the ModSecurity core rule set, you download the rules and you open it up, there's this activated rules directory. Actually, we'll do this just to give you some idea of where we are. Hold on. Do a longer listing. That's not panning very well on here on the smaller screen. Well, there's a bunch of different directories of different rule sets that you can use. We have what we call base rules, which are obviously named. Those are the base rules that most everybody would want to activate. We have some optional rules where depending on your platform, you may not want to add those in. Experimental rules is where all the AppSensor stuff is being tested today. But actually go in here to the activated rules, just so you can see the ones that I'm working on here. 1 second. So you can see down here, I'm going to be uploading those to the SVN repository. For the core rule set, I didn't have a chance to do that yet. But you can see how they're named, just the naming convention. So it's AppSensor detection point, and then it'll tell you it's related to the parent category. So you can go inside there and start to look at the rules. Okay, so oops. Got to pull up the right line. Where's it that? Let me scroll down here. All right. So what's interesting in trying to profile all this stuff is you have all these rules that ModSecurity looks for by default. You know, all the stuff that it would block and say, hey, this is bad, this is bad. So before we start to profile stuff to learn what is good behavior, you want to make sure you're not learning the bad stuff, right? So that's what this does right here. You have a group of rules that at the end of the whole request cycle, if you've ever run Apache or you've ever looked at the request cycle loop, this is hooked into the post-processing logging hook. So request comes in, it goes out. After all that is done, then we're going to go in here and we're going to do a few checks. So some of the stuff, like for example, right, we don't want to profile anything if it's a 404. File's not there, you're done. Just skip it. If the status is a 400 or 500 level status code, right, and something's wrong, we don't want to profile that. Okay. The core rule set, when you run it, if it identifies that anything's bad, it tracks an anomaly score. So if there's an anomaly score that's above 0, meaning it found something wrong, we don't want to profile that either. Right? We're trying to get to kind of clean requests so then we can make some decisions. Okay, so down here is the Lua API. So if we make it through all that and we say, hey, this probably looks like it's a legit request. Nothing malicious is going on here. Let's go ahead and profile it. You can see it says secrule script. You point it to your Lua script, and then it runs. So this isn't going to try and block anything because essentially it's too late anyways. Request came in, response went out. What this is doing in the background is learning. And then the user can set up a threshold for how much traffic they want to monitor. You can say, hey, I want to see 5,000 requests or 50,000. I mean, whatever it is, you can pick and choose. And then at a certain point, after it hits your threshold, then it will set a certain variable, and it'll say, okay, from this point on, now we're going to enforce this profile. So all the blacklist stuff in the core rule set always runs. But at a certain point, you also then get this positive security model. And it's going to go ahead and do all types of different kinds of profiling. Go back in here. So ModSecurity has the idea of persistent storage, which becomes very useful if you want to try and track things beyond one request. That's a key differentiator between like an IDS or IPS, right? A lot of times they'll just look for, oh, is something wrong here? No, go ahead. Okay, so we have this persistent storage, and this is showing you, looks like a lot of data, of course, but this is for one resource. It's got between, I don't know, 2 and I think 4 parameters on it. And this is all the stuff the Lewis script learned about it. So you have all these different sections in here where we know the minimum number of arguments and the maximum. Once you know that, then it becomes easy to enforce it. You can categorize a lot of these parameters, like this parameter that's the class is a path, right? So it's a path to a file. Another one's an email address. Other one's all digits. So you can let this run in the background. Once it sees enough, then you can start implementing those AppSensor detection points, and it'll start triggering those. So this is getting back to, from the previous circle, talking about the developers, the idea in this case of identifying SQL injection. That may be tough for developers to come up with all these regexes or ways to say, hey, this doesn't just match my positive security profile, but this is SQL injection. So this is one of the things that we do with the core rule set to try and make it better at detecting that kind of stuff. We had a challenge over the summer. And what was interesting was we wanted people to QA our rules. And actually, I see Michael Coates is in back. He gave a talk earlier about bug bounty programs, right? So it's kind of a similar thing that as good as we thought we were doing internally with these rules, we said, we got to put it out in the public, right? There's people that do this as their job. There's people that do it illegally as their job. But there's people that will poke and prod at this and find holes. So we said, let's do a challenge, and let's make it targeted, just SQL injection. And I was trying to figure out, how can we do this so we have an application they can interact with? And I didn't want to build stuff. And then have people hack it and then have to figure all that out. So came up with the idea, if you can see the links there in the middle, I said, wait a minute. Public commercial scanning vendors already have public demo sites, right? So you can go download their dynamic scanner, run it against their demo site, and get a nice shiny report. So I said, why don't we leverage that? That's the site with the hole in it. Now we just need to somehow put us in the mix to look at this stuff. So what we did is we set up those links. If you come here to participate in the challenge, you click on the link, you go through the modsecurity.org website, we just proxy, and we sit passively, and we watch. And what happened was, the challenge was to say, each one of these websites has SQL injection issues. There's a backend database not protected appropriately. The challenge was for them to extract out database information. What database type was it? What was the name of the database, a column name, and extract out some data from a table. And we said, okay, level 1 is speed hacking. How quickly can you do this? We said go. The 4 people on the right found it relatively quickly. Level 2 was what I was really interested in. That's an evasion challenge. So what we were showing up at the top, 1 second, I can actually show this real quick since we got a little time left. Let's see if this is going to come up. Projects. Hop through this real quick. Oh, a second. All right, we can go to one of these. Let's see if this is going to work. Okay. So as they're interacting with the website, we're passively watching everything. And if we see something, we prepend a warning banner to the top, just to let the end user know. Okay? If we were in a blocking mode, we would have blocked that because we saw you were doing something bad. So the level 2 challenge was go in, extract out the database information that we asked for. However, you can't have a warning banner triggered. If you do that, that's an evasion. You win. Let us know, and we send you a T-shirt, and we put your name up on the big board and all that stuff. So it wasn't a bug bounty program. Much smaller in scope, a one-off, but I definitely see the value in it. And what we're able to do then for the core rule set was we did a lessons learned. We're able to go back and analyze. There were 9 different guys or groups that figured out the evasions, and we could go back and look because we had the full audit log, right, of everything that happened, whether it triggered an alert or not. And you could look at them and say, oh, crap, yeah, why didn't we catch that? Some of it were encoding issues. Some of it were because of false positives previously. We weren't looking in certain places, such as cookies, and there was an evasion, or there was a vector in one of the cookies, and we weren't even looking at it. So some of them were config issues. It's a lot of the same stuff Michael was talking about, lessons learned. But it's this kind of stuff that you can then go back on. So the detection for SQL injection, in this case in the core rule set, is getting better and better all the time. We're probably going to have more challenges like this. But it's this kind of stuff when you think about inside the code, it's good to have the detection point there, but for SQL injection, how often can you update that and get it pushed out? Because it needs to be constantly updated. We were talking about that a little bit at the AppSensor Summit to figure that out and say, well, you don't want to be pushing new code. Maybe this could be brought in dynamically, periodically through a config file. You know, you need to make it more agile so it can be updated because these things certainly aren't static. All right. So this is an interesting detection point that we had added in, and it really is this concept of like a layered approach. So if you think about the architecture coming in, somebody's going to your web app, if they go through ModSecurity, we may or may not be in the best position to make a decision to block it, right? But what would be cool is if we can look at it, like for SQL injection that we just saw, and say, hey, this looks like SQL injection. I'm going to let this request go on to the destination app server. It has AppSensor detection points. We're kind of working together. I need to tell AppSensor I saw SQL injection, so it can factor that in. So with this concept of suspicious external behavior, in this case, it's external to the application. Something else has said something weird's going on. So to show you an example here, well, it's going to be hard to read from the back of the room. It's very similar in concept to like spam monitoring and tagging and SMTP and emails, right? You ever get those spam emails and you look at the raw headers and you can see everything. Saying, oh, Spam Assassin or whatever you're using, it checked this, here's this score, and finally it said it's spam. We want to take that concept to the web. The other analogy I gave to somebody who really wasn't very technical is if you've ever watched those wilderness shows like, what was it, Mutual of Omaha, right, when I was growing up, all of those. Right? The idea that, oh, here comes the rhino, you shoot the rhino, falls asleep, you go in, you tag it, you do all that stuff, you categorize it, and then you watch, and then it wakes up and runs off. It's the same kind of thing. It came in, we saw it. What we want to do is tag it. So the idea is ModSecurity sees something bad. It exports this information to Apache as environment variables. And then Apache adds in 2 new request headers. There's one up here. Is this thing have a... Hey, there we go. There's this header here called XWAF event. And we can export all the different rules that triggered, the messages. And then down here is an XWAF score. You can see the total anomaly score is 35, and 12 of that was SQL injection. So we can export that, send it on its way, and if the destination application server has certain logic that can look for those request headers and take that, it can say, let's throw an exception for SQL injection, because they said there was one, and then we factor that into maybe a different type of response action. A couple other interesting detection points that we've added in. This one, as it says, suspicious client-side behavior. So there's all sorts of weird stuff that can happen inside the browser that traditionally, from the web server perspective, we have no idea what's going on in there, right? That's why cross-site scripting is such a big problem, especially the DOM-based stuff. We just have no insight. So the idea here is, if you leverage something, I think it's in the middle here, if you can see that content security policy, right, CSP, if you've heard that for Mozilla, Firefox. It's the idea that as an organization, you can define for your website different controls about what dynamic code is allowed to run. What's allowed to run at all? Where is it allowed to run from? And actually, Michael, this is good from our summit discussion, that I think the process that organizations need to go through for CSP creation is very similar to AppSensor. You know what I mean? For the relevant parties, because you need to get operations folks in because they're adding in these these response headers, and it's policy questions on how this is going to work. You need developers at the table. You need OpSecurity, InfoSec. Get those people in a room. So the idea here is you can define for your website, send down in a new response header, if it's Firefox, and say, hey, here's restrictions about what code's allowed to run. Then if any of those are violated in the browser, you can optionally, of course, take action on it. But then the browser can send back a new reporting request to the website and report back whatever weird thing happened client side. So I did this as a good proof of concept. I did all this in ModSecurity. So ModSecurity can be used actually to define the CSP policy to push down to the client. You can do that in the config files and set that up. And again, I know it's hard to read from the back of the room. Just grab this with live HTTP headers just to see when the client was going to our site. We highlighted the new response header. That's now pushing that policy down to Firefox and CSP. And then if something weird happens, in this case, there was some JavaScript that came in and it was doing an iframe to third party, and it was trying to pull up some malicious code. But the domain it was going to pull it from was not within the policy. So the browser says, oh, hold on a second. It makes a new web request. You can see here it's doing a post to a certain URL that we specify. And then down in the bottom, it's this blob of text. So I guess it's JSON, but from our perspective here, it's a blob of text because we don't parse JSON currently. Another interesting one here is this idea of honey trap. And this, again, to me, is a real good example that when you're talking with developers and going through all this, when you get to this category, this isn't necessarily something I think developers have to implement. It's useful as a detection point in operations, but who implements it is a discussion you'll have to figure out. But a good thing to do, why you think InfoSec should be in the room, is you want to get the attacker's perspective and say, if you're going to assess our site or attack our site, what are the steps that you do? And then you can highlight along the way, oh, I could put a little trap here. And if you start to mess with that, then real low false positive rate, you know somebody's messing around with your website. So a good example, this is the example we have here in ModSecurity, if you want to do the CSP one. ModSecurity has the capability, when the response body is going out, you can actually manipulate the response. It used to be you could only prepend stuff to the top or append it to the bottom, but now we updated a new function where you can basically do regex substitutions. So this one, the way we made it real easy here is we had trapped the closing HTML form tag, and if it sees a form going out, it prepends it with this bogus hidden parameter. Now, of course, you need to figure out and make sure what that data is, that you don't blow something up by mistake, right? If an application receives this crazy weird parameter it wasn't expecting, how's it going to react? But this kind of stuff is perfect for a honey trap. Because if you're talking about an attacker, an assessment person, whoever, they're going to start looking for these hidden variables and parameters, and they're going to start messing with them. Especially if they see something called, oh, hidden name, this is called debug, and it's false. What am I going to do? I'm going to change it to true and see what happens, right? So you're laying these little landmines because now it's very easy server-side in ModSecurity. We have a rule that just enforces this. If it ever sees a parameter called debug, and if it's ever not false, somebody's messing around. And it's not average Joe in the browser because they never see this. It's somebody who's savvy enough to get out of the browser, start to manipulate things, and they're poking, and you want to keep a closer eye on them. Again, I know it's tough to read from the back of the room, but this is the event that triggered. If somebody messed that up, so you can see the message tampering of hidden parameter, honey trap data, and it captures the data where they had changed it to true. So on the back end, what's cool though is all these different detection points, if you have these types of alerts, whether it's ModSecurity creating it or internal to the app, it doesn't matter, feed this stuff to a centralized location. Like I mentioned before, a SIM or something. So that way, real time, people monitoring, they can correlate all this stuff. And the last one to show here is response actions. I haven't gotten too deep, from the project perspective to do this, just because I'm doing detection points first. Then we move on to the actions. But one I did want to highlight here, and actually I think I have the blog post to kind of walk you through. It's kind of interesting. Move over here. Hopefully we can see it a little better. It's the idea of an application logout. So yes, you need to figure out under what circumstances would you want to trigger this, but this is something typically external to your application that other devices don't normally do, because you have to make this external device authentication aware. It needs to understand how does somebody log into your site, but then also how does somebody log out, more specifically. So actually, let me scroll down. Just wanted to highlight a couple of these. All right, so walking through the process of how somebody logs in, right, and how it's tracking them. Obviously, once somebody logs in this case, I just did against WebGoat just to quickly show something. But after they log in, the application should give out a new session ID, right? JSession ID 749, whatever it is. Okay, yes, WebGoat. Now, the trick now is how does somebody log out? So if you wanted to implement this action, you need to know, okay, what do? They go hit the button log out. Yeah, okay, but how does that look on the wire? So in this case, in WebGoat, it'll pass a new parameter, logout equals true, and the key piece you need is the actual session ID. And WebGoat also does basic auth. Probably don't have much of that in the real world, but that's how WebGoat has it. So to define this, go down here. In ModSecurity, the way that I implemented it in thus far is at the end of the request cycle, we have a couple rules here that do the anomaly scoring validation to check what the anomaly score is. Do you want to do blocking, things like that. So what I did is I was able to update it with a couple of different actions here. So we're saying if the anomaly score is over whatever threshold you're going to set to take this action, what we want to do is we want to capture from the live request, the person that's attacking and who's logged in, we want to capture the request cookies. That's what this macro does, grabs whatever their current cookie is. In this case, it's JSessionID. And because WebGoat's doing the weird stuff, we also have to grab the basic auth header. So we grab both of those, and then we fire off this external script. Logout sh. Okay? And you can see here, the script is very, very fancy. It's just calling up curl. Right? But as a third-party device, once we see this, not only do we want to block what that user was doing because it's gone over our anomaly score, in the background, we fire off a new client request with their data. Looking here. Let me go down. Right? So this request actually gets sent to the web server, but it's from us. So that way, it would forcefully log them out. Now, if they go to get back in, they'd be kicked out and have to go back to the login page. Now, what was interesting in implementing this in the real world, what we're finding with a number of apps, unfortunately, is logout defects, right? Where what the application was doing was when you press logout, all it did was send down new cookies, like delete cookie, but it didn't expire at server side. Yeah, so we're firing this thing off to kill it. Meanwhile, the bad guys just doing what they're doing because they're submitting that same one and server side said, oh, it's still good. So after that lesson learned, I had to go back in. Because there's another AppSensor detection point where we can track the session IDs as well, and we have session types of detection points. One of the things we track is when the application hands out the set cookie after you log in, we mark that cookie as valid locally in ModSecurity. We know that's one that the app gave out to you after you logged in. That way, if people are trying to brute force other ones, they won't be valid, right? So the other thing that we can add on down here, and here's the checks that we do, I added in this update down here, where when we fire off that script to log them off, locally in ModSecurity, we also mark that cookie as invalid. So that way, if they try and reuse it, regardless of if it's sitting there in the application and it could be used, we're saying it's not valid. So if they hit us first, we're going to block it and say it's not good. Okay? All right, and I think that was it. So I know that's a real quick run through. I just wanted to give a status of what we're working on and to give you some ideas on detection points that you could do externally. I will ask if anybody wants to help. We always need help with the rules. We have an active mailing list if you want to help out. You can actually go, in this case, either one. On the AppSensor one, there is a lot of overlap in how we're figuring out these detection points. On the detection point, I didn't highlight it on there. Each of those detection points on the project page at the bottom, there's little links that will go to example code. Like for Java, there's a lot more there because there's Java code that's been worked on. But like PHP and ASP.NET or ASP, a lot of that, there's no code snippets for. But I'm going to go in, and as I'm doing these in the core rule set, I'm going to go in and put links to those as well. But if you want to help with implementation of any of these, I'm sure just let project leaders know and sign up for the mail list and hopefully get some more help. All right, thank you for your time.